Okay, so here we go again. This is the homework for tonight, which I want you to really understand so when you come to class, we have a better understanding. Alright, in this case, you need to come up with your own diagram, your own picture. So, again, this is a letter problem. So, right here. So I know I'm going to have a right triangle. Okay. The first measurement that I know is the ladder, so it's constant. So I can basically put it on my picture. So I know that this is 10 meters. Okay. Now they're telling you, let's break this down, that is basically sliding down. So it's sliding down along the vertical wall. So this is the wall right here. So it's dropping down. While the base is being pulled away, so this is the base, I'm going to pull it away, that way, at a speed, so okay, I'm going to put variables in X and Y, so I know I'm going to have the rate in which Y is changing. I know that there is a rate in which X is changing. So as I start moving the ladder, pulling it away, I know that I'm at a particular rate. How fast am I doing so? So I know dx dt will be the rate. I know dy dt will be the rate in which this particular top of the ladder is sliding down. So let's find what is given. The top of the ladder right here is sliding down on a vertical wall while its base is pulled away from the base. So here's the base of the wall right here. This is the wall right here, and this is the base. Okay, at a speed of 1/4 meters per second. So the rate in which I'm pulling the ladder from the bottom, dx dt, that's the rate in which I'm pulling the bottom of the ladder, is 1/4 meters per second. How fast? I know the rate. What's the rate? Is the top of the ladder. So how fast is the top of the ladder? Here's the top of the ladder sliding down when its base, when it is 6 meters above the base of the wall. So this is what I picture. How fast, so this is where I started. I want to know when the height is 6. Right there. When it's above the base of the wall. So I want to know exactly right there. So find dy dt, how fast did it move down? Find dy dt when the ladder right here is 6 meters above the base of the wall. So the ladder is right here. Here's the ladder. Dun, 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 dun. And I want to know when it's 6 feet. Right there. When it's 6 feet above the base of the wall. So what measurement do I really have? In this case, the measurement that you really have, it is not X that is given, but it's 6. Because the ladder, now I want to know exactly when it is 6 feet above the base of the wall. So when Y equals 6 meters. Okay? What equation relates X and Y in 10 meters? Again, Pythagorean theorem. I know that Z is 10 squared. Differentiate with respect to time. So the derivative with respect to time, x squared plus y squared. The derivative with respect to time, 10 squared. 2x, different variables, dx dt, plus 2y dy dt, and that equals 0. Okay? What information do I know that I can substitute? I know dx dt, it is 1/4. Red and red. I know x, no. Do I know y? Do I know y? It is 6 meters. Do I know dy dt? No. That's what I'm trying to find. So I want to know the rate in which the top of the ladder is dropping. How fast is it dropping at the instant when the ladder is 6 meters above the base of the wall? Alright, so again, let's find the missing information. Again, I take this equation. That's my equation that relates everything. I know x squared plus y squared equals 10 squared. What information do I know? I need to find x. Y is 6 meters. 10 squared is 100. This is 6 squared. X squared plus 36 is 100. X squared is 64. 64. Take the square root. X equals plus or minus 8. And again, do I need the minus? No. So now let's go over here. So I know x equals 8. Okay. So 2 times x, which is 8, dx dt is 1/4 plus 2y dy dt equals 0. So now that factor of 2, it can divide by 2, can divide by 2, can divide by 2, and I still have 0. So that goes away because it's a common factor. 8 over 4, what do we get? 8 over 4, that gives us what? Oh, I forgot one variable. What's my variable here? 6. Y is 6. I forgot y. Look at this. Y right there is 6 meters. So that gives you 2 here plus 2 times 6. That gives you 12. Oh my god. That gives you 6. Stupid. Dy dt. I'm sorry, I shouldn't have said that. I'm sorry. So that becomes 6 dy dt equals -2. I subtracted the 2. Divide by 6. Divide by 6. So you get dy dt is -1/3. Y, what are the units of y? Is meters. Time, what are the time units? Seconds. So, and it makes sense that it's negative because it's basically dropping. So that's why we get the negative. Okay? So now, let's answer this question. This is the best part. Erase. Alright, here we go. So, the top of the ladder is slipping down at a rate of, do I write negative? No. That negative is already taken care of with this particular statement, slipping down. At a rate of 1/3 meters per second, when it is 6 meters above the base of the wall. Bingo. Yay.